On this Ram 2500 HD with the 6.4 gas engine, P0353 points to a possible problem in the ignition coil 3 primary or control circuit. In plain terms, the PCM may not be seeing the coil driver current it expects for that coil. The truck may set the MIL, and depending on the failure, it can run rough, misfire, or act intermittent. Broadly, you're thinking about the ignition feed, the coil control circuit, the coil and plug area, connector condition, and in some cases the PCM coil driver. Start with the basic system checks before getting deep into the pinpoint tests. The ignition coils are supplied 12 volts from the fused ASD relay output circuit. For this code, the PCM is watching the ignition coil 3 signal circuit. The monitor runs continuously with the ignition on, and the code sets when current is less than or equal to 0 amps for at least 2 seconds. Treat those as the monitor gate and setting formula, not as a reason to jump straight to a part. First, scan every electronic control unit, record the codes, save the scan report and related recorded data, then clear the codes. Turn the ignition off for a minimum of 0 seconds, turn it back on, and operate the vehicle under the same kind of conditions that set the fault. Then read the codes again. If P0353 comes right back, continue with the circuit diagnosis. If it does not return, handle it as an intermittent condition instead of forcing a hard fault test path. Next, look at the recorded codes and see whether any ASD-related faults are present. If they are, diagnose those first, because the coil feed depends on that relay output. If there are no ASD faults, move on to the coil power supply load test. Now load test the relay output power supply circuit. The procedure has you disconnect the ignition coil harness connector called out for access to the power supply circuit, connect the positive lead of the load test tool to that power supply circuit, and connect the negative lead to battery ground or chassis ground. Make sure the circuit is actually powered on. If it is an ignition feed, the ignition has to be on. If it is relay output, the relay needs to be energized. Compare the bulb brightness to a direct battery connection. A good circuit should light the bulb bright. If it is not illuminated and bright, repair the power supply circuit for an open or high resistance, then verify the repair. Be careful with the load tool here. A 12-volt test light can only stand in for the load test tool if it draws enough current to load the circuit. Many high-impedance test lights draw less than 0.1 amps, which is not reliable for this check. The tool should draw more than approximately 0.75 amps for a proper load test. If the power feed load test passes, check the coil 3 control circuit operation. Connect a 12-volt test light to a 12.0-volt source, probe the coil 3 control circuit at the ignition coil harness connector, and crank the engine for 0 seconds while watching the light. Stay clear of the fan, belts, pulleys, and loose clothing while the engine is cranking or running. If the light blinks brightly, the driver command is present, so continue to the spark plug inspection. If the light stays on constantly, go after a possible short to ground in the control circuit. If the light stays off constantly, go after a possible open or high resistance in the control circuit. When the control light is blinking brightly, turn the ignition off and remove the spark plug or plugs as required. Inspect for cracks, carbon tracking, foreign material, gap size out of specification, and a loose or broken electrode. If one of those conditions is present, replace the spark plug. If carbon tracking is found on the plug, inspect the ignition coil boot for damage and replace it if necessary. If none of those spark plug conditions are present, the procedure calls for replacing the ignition coil and spark plug, then verifying the repair. If the test light was on constantly while cranking, isolate the coil 3 control circuit and check for a short to ground. Turn the ignition off, disconnect the ignition coil harness connector called out in the test, disconnect the PCM harness connector, and check for continuity between ground and the control circuit at the ignition coil harness connector. If there is continuity, repair the control circuit for a short to ground, using the circuit path and any inline connectors to help isolate the short, then verify the repair. If there is no continuity, Continue to the coil swap check before condemning the PCM side. If the test light was off constantly while cranking, isolate the coil 3 control circuit and check for an open or high resistance. Turn the ignition off. Disconnect the ignition coil harness connector called out in the test. Disconnect the PCM harness connector and install the GPEC Diagnostic 10436 adapter at the appropriate PCM harness connector. Do not probe the PCM harness connectors directly, because that can damage the terminals and create a poor terminal-to-pin connection. Measure the control circuit resistance between the ignition coil harness connector and the PCM harness connector. Remember, the GPEC diagnostic adapter can add up to 1.5 ohms of resistance. If the resistance is below 3.0 ohms, continue to the coil swap check. If it is not below 3.0 ohms, repair the control circuit for an open or high resistance. Then verify the repair. Before replacing a PCM for this fault, determine whether the ignition coil itself may have caused the driver failure. An internally shorted or damaged secondary coil circuit may be involved, so do not replace the PCM until this check is done. Remove the ignition coil controlled by the driver that set the code and install it in another coil location that did not set a fault. Turn the ignition on, clear the codes, then start and run the engine for up to 1 minute. If the engine will not start, crank the engine 3 times for 10 seconds. Read the codes again. If a correlating fault sets for the new coil location, replace the ignition coil, replace and program the PCM, then verify the repair. If a correlating fault does not set for the new location, move on to the connection checks. If the coil swap check does not move the fault, check the related PCM and component connections. Perform any applicable service bulletins. Disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Inspect for poor connector installation, damaged locks, corrosion, signs of water intrusion, damaged seals, bent terminals, overheating from poor connection, push-back terminals, spread terminals, and poor terminal tension. Repair anything you find, then reconnect everything fully seated with the locks engaged. Clear the codes, operate the vehicle under the conditions that run and set the monitor, and read the codes again. If P0353 returns at that point, replace and program the PCM, then verify the repair. If it does not return, the wiring or poor connection problem has been repaired. One important caution on this diagnostic path. The target code is for ignition coil 3, but some connector callouts in the test path name a different coil connector. Do not guess at the connector. Pause, recheck the earlier diagnostic path and circuit identification, and make sure you are on the correct control and power circuits before disconnecting, measuring, or repairing anything. Keep verification separate from the pinpoint testing. After any repair, run the powertrain verification, operate the vehicle so the monitor can run again, and confirm the code stays gone. The takeaway is simple. Prove the feed, prove the coil control circuit, inspect the plug and boot path, move the coil only when the test path calls for it, and do not condemn the PCM until the coil and circuit checks support that call. For more diagnostic training, visit stepdiagnostics.com.